Atlas is not on a collision course with Earth. Its closest approach on December 19th will be 269 million kilometers away, nearly twice the distance to the Sun. But here's the question nobody wants to ask publicly. What if it changes course? We've measured non-gravitational acceleration. We know Atlas is moving in ways gravity alone cannot explain. If it can change its trajectory once, it can change it again. This is the collision scenario nobody wants to talk about, because discussing it sounds alarmist, sounds like science fiction, sounds irresponsible. But if Atlas is artificial, if it has propulsion capabilities, then trajectory changes aren't science fiction. They're engineering. And December 19th, when it makes closest approach, might be the optimal window for a maneuver. Let me walk you through what this scenario would actually mean, based on physics, orbital mechanics, and what we know about Atlas's capabilities. So let's explore it rationally, carefully, with full acknowledgement of how improbable this is, but also with recognition that improbable isn't impossible. First, the current safety facts. Atlas's trajectory is well established. JPL has calculated its path with high precision. Based on gravitational physics alone, it will pass 1.8 astronomical units from Earth. That's safe. That's not even close to threatening. The non-gravitational acceleration measured at perihelion was modest, 135 kilometers per day squared radially away from the Sun, and 60 kilometers per day squared transverse. That's enough to deviate tens of thousands of kilometers over a month, but not enough to redirect toward Earth from its current path. If Atlas were trying to hit us, it would need to execute a massive trajectory change. And we would see it. The acceleration would be dramatic, obvious, unmistakable. We're not seeing that. So why discuss this scenario at all? Because of what Loeb's mothership theory actually proposes. The idea isn't that the 5-kilometer object itself impacts Earth. The scenario is that Atlas, if it's a technological mothership, might release smaller probes, objects that can maneuver more aggressively, components designed for close planetary approach. This is what Loeb meant when he talked about Atlas potentially sending Christmas gifts to humanity, not the main body impacting, but smaller craft released toward Earth and other planets. That scenario is less catastrophic but potentially more significant. Not an extinction event, but first contact. Not destruction, but visitation. But let's explore the full collision scenario anyway, because it's instructive about scale and capabilities. Atlas has a minimum diameter of 5 kilometers and an estimated mass of 33 billion tons. For comparison, the Chicxulub impactor that killed the dinosaurs 66 million years ago was approximately 10 kilometers in diameter. Atlas is half that size, still enormous, still capable of global catastrophe. A 5-kilometer object impacting Earth at interstellar velocities, around 60 kilometers per second, would release energy equivalent to billions of nuclear weapons. It would create a crater hundreds of kilometers wide. It would trigger global climate disruption. Mass extinction would be likely. This is dinosaur killer scale. This is what planetary defense systems exist to prevent. And here's the disturbing connection. Loeb's recent Nature paper examined whether the Chicxulub impactor might have been kicked toward Earth by a passing star disturbing the Oort cloud. The timing coincides with when early humans were emerging. In that paper, a question was posed. Was the Chicxulub impactor a predecessor of 3I Atlas? The implication being, if life was seeded on Earth by an interstellar gardener, that gardener might also reset terrestrial life when it goes in an unwanted direction. It sounds like science fiction, but Loeb published this in Nature. The connection between interstellar objects and mass extinctions is now in peer-reviewed literature. So if Atlas were to change course toward Earth, We're talking about an object with sufficient mass and velocity to trigger global consequences. Now, could it actually do this? What would be required? Orbital mechanics provides clear answers. The Oberth effect, used by every interplanetary mission, says the most efficient time to change velocity is at closest approach to a massive body. You fire your engines when you're moving fastest, when you're nearest the gravitational well. For Atlas, that optimal moment was October 29th at perihelion, closest to the Sun. Maximum velocity, maximum efficiency for any propulsive maneuver. We measured non-gravitational acceleration at that exact time. If Atlas has engines, it used them at the textbook perfect moment. But that acceleration was aimed away from the Sun, not toward Earth. It was gaining velocity to leave the solar system faster, not redirecting toward our planet. December 19th offers another window. When Atlas passes closest to Earth, it's at a different position in its trajectory. A burn at that moment could adjust its path for a return pass years in the future. But here's the physics constraint. To redirect a 33 billion ton object onto a collision course with Earth from its current trajectory requires enormous delta V. Change in velocity, propulsive capability. Current measurements show modest acceleration, nowhere near what would be needed for Earth impact. Unless Atlas is capable of much more thrust than it's currently displaying, the collision scenario isn't viable with measured capabilities. But, and this is the critical question, what if it's holding back? What if the acceleration we've seen is minimal maneuvering, and it has much greater thrust available? We don't know, we can't know until we measure maximum capability, which might only become evident if it chooses to reveal it. So what could we actually do if Atlas suddenly changed course toward us? Honest answer, not much. And the timeline matters critically. Planetary defense against asteroids relies on early detection and gradual deflection. The DART mission demonstrated we can change an asteroid's trajectory by impacting it with a kinetic projectile. But DART hit a small asteroid, about 160 meters across. Atlas is 5 kilometers across, 30 times larger in diameter, thousands of times more massive. A DART-style impact would be like throwing a pebble at a freight train. We would need multiple large nuclear devices to deflect something Atlas-sized. And we would need years of advance warning to design, launch, and execute the mission. If Atlas changed course tomorrow, aimed at Earth with arrival in weeks or months, we couldn't stop it. Our planetary defense infrastructure isn't designed for objects this massive on hyperbolic trajectories with short warning times. Nuclear deflection requires precision and planning. You can't just launch missiles at incoming objects and hope for the best. The physics of momentum transfer, fragmentation risk, and trajectory modification require careful engineering. Detection to impact time frame matters enormously. We have systems monitoring for near-Earth asteroids continuously. We would see trajectory changes in Atlas immediately, but response time from detection to effective intervention measures years for objects this size. So the collision scenario, if Atlas suddenly accelerated toward Earth with arrival in under a year, we would be essentially defenseless. We could evacuate potential impact zones if we knew where it would hit. We could prepare for aftermath, but we couldn't prevent the impact itself. That's sobering. That's the honest assessment of our capabilities. Planetary defense works against smaller objects with years of warning. It doesn't work against 5-kilometer interstellar visitors executing surprise maneuvers. But, and this is crucial, that scenario requires Atlas to have enormous propulsive capability that it hasn't demonstrated. It requires intent to cause harm. It requires motivations we can't even guess at. And Loeb's mothership theory suggests a completely different scenario. Not the 5-kilometer body impacting, but smaller probes being released. Think about the geometry. Atlas approached Mars, Venus, Earth, and Jupiter on this pass. Perfect ecliptic alignment, optimal for visiting multiple planets. If it released probes at perihelion, when it had maximum energy available, those smaller craft could use gravity assists to reach Earth. They wouldn't need to carry the entire 33 billion ton mass, just payloads of hundreds or thousands of tons each, car-sized probes, building-sized structures, objects small enough to maneuver efficiently, but large enough to carry instruments, communication equipment, whatever an interstellar mission might require. Those wouldn't cause global catastrophe. They'd cause first contact. What would we do? Honestly, we'd watch, we'd track, we'd try to communicate. And if they entered our atmosphere, we'd document everything possible. December 19th is when we'll be watching most carefully, not just measuring Atlas itself, but looking for accompanying objects, fragments that separated at perihelion, smaller craft on independent trajectories. Observable indicators of intent include sudden trajectory changes visible in orbital tracking, velocity increases beyond what natural outgassing could produce, release of multiple components visible as separate objects in tracking data, radio transmissions or other active signals, and deviations from pure ballistic trajectory. We have the detection capability, ground-based telescopes, space-based observatories, radar systems. We would see activity. The question is, will there be activity to see? So here's the engagement question for you. And this is purely hypothetical, just for fun. Highly unlikely scenario exploration. What would you do if Atlas changed course toward Earth tomorrow? Not asking for panic responses, asking for interesting ideas. How would you prepare? What would you prioritize? If you had weeks of warning that an interstellar object was approaching on a collision course, what would be on your personal checklist? Drop your thoughts in the comments. Best ideas, most creative preparations, interesting perspectives on how you'd spend potential last weeks. Remember, this is speculation, thought experiment, improbable scenario discussion, but it's worth thinking through. Because unprecedented situations require unprecedented responses, and hearing diverse perspectives is always valuable. Now let me bring this back to reality and probability. The collision scenario is highly unlikely. Atlas's current trajectory is safe. Its measured acceleration is insufficient for Earth impact. There's no evidence of hostile intent, no indication of threat, no reason to expect sudden trajectory changes. We're discussing this because if Atlas is artificial, then trajectory changes are theoretically possible, not probable, not expected, but possible. And in planetary defense, you prepare for possibilities even when they're unlikely. You think through scenarios. You identify response limitations. You develop protocols. That's not fear-mongering. That's prudent planning. The more likely scenario, if Atlas is technological, is probe release rather than impact. First contact rather than catastrophe. Scientific opportunity rather than existential threat. But we're watching. December 19th, every major telescope will be pointed at Atlas, tracking its exact position, measuring velocity, looking for deviations, checking for accompanying objects. If something changes, we'll see it. We'll have data, and we'll respond appropriately. The reassuring truth is that space is big, trajectories are well understood, and we have good detection capabilities. Surprise. Impacts from objects we're actively tracking don't happen. We see trajectory changes. Atlas is under more scrutiny than any interstellar object in history. IAW coordination, Webb and Hubble observations, global telescope network. If it does anything unexpected, we'll know immediately. So should you worry? No. Should you prepare for collision? No. Should you think about interesting responses to the hypothetical scenario for fun? Sure. This is balanced assessment. acknowledging theoretical possibility while recognizing extreme unlikelihood, exploring scenarios without creating alarm, thinking through what if without suggesting what will. The collision scenario exists in the realm of very low probability but high consequence events. Worth thinking about, not worth losing sleep over. Atlas is probably natural. If it's artificial, it's probably not hostile. If it has propulsion, it's probably not aimed at us. If it releases probes, they're probably for observation, not attack. Multiple layers of probably, each one making the catastrophic scenario less likely. But the universe surprises us. Nature is more imaginative than we are. And December 19th will give us data that narrows possibilities. Until then, we watch, we measure, we stay curious, and we keep telescopes pointed at the most fascinating interstellar visitor humanity has ever detected. What would you do if Atlas changed course? Let us know in comments. And remember, this is speculation for engagement and thought experiment purposes. The actual risk is essentially zero based on current data, but exploring possibilities, even unlikely ones, is part of how we prepare for and understand our cosmic neighborhood. Stay curious, stay informed, and we'll bring you the December 19th results when they arrive.